The job ran every week against my firewall image, checking for known vulnerabilities. Week after week it came back green, and every run it ever made scanned nothing. The file it checks was deleted 3 steps earlier in the same job. This is one real problem, start to finish, me and an AI agent, who did what, and how little calendar it took. For some context, geekdojo is one person. Rasputin, a cluster OS, a control plane, a firewall image, ships at a pace that looks like a team because of a standing arrangement. AI agents research, build, and open pull requests. I direct, decide, and merge. Every merge is a human clicking the button. The work item this video follows is one line from one day. The shipped images needed a CVE watch. It sounded like a simple ask, but it certainly didn't stay simple. Step 1 wasn't code. I had the agent research the space first. How do teams actually watch CVEs on embedded images in 2026? With one rule I insist on. The research has to try to disprove itself. 24 sources went in. The top 25 claims each got adversarially verified, separate passes attacking each claim. 23 survived, 2 were refuted outright. One refutation mattered here. A promising CVE tool's data source could not be confirmed to query the real vulnerability databases. The claim died in verification, so we never built on that tool. Research that only collects supporting evidence is marketing at best. This step exists to kill bad plans while they're still cheap. The research also returned one constraint every credible source agreed on. Agents find, fix, and open PRs a human merges. That constraint shaped everything after. Before writing anything, the agent mapped what already existed. Finding the firewall repo had already had a weekly CVE job. Scanners wired in and everything. The actual gap was the node OS, which had nothing. So the plan adjusted, build the OS watch fresh, and audit the firewall's existing ARM instead of duplicating it. The audit came back with a flag I want to read almost verbatim because it's the hinge of the whole story. The scanners are being fed the raw image file. Likely a near no-op, needs a validation run before trusting or changing anything. An audit that says, I suspect this is broken, verify before acting, is worth 10 that say looks good. So we went back and forth. I said run the verification. It found something worse than the flag suggested. A grub patching step compressed the image in place, deleting the uncompressed file the scanners were pointing at. The scanner's complaint went to standard error in a step built not to fail on scanner errors. Green every week, scanned nothing, ever. 0 findings looks exactly like a healthy run when there's no baseline and nothing expected. The obvious move is fix the path. Done, I said, fix the path and rerun to measure what the scanners actually see. That second instruction is the one that mattered. Measured against a real intact image, Trivy flags the whole thing as an unsupported OS and hands back an empty report. It can see the packages, it just can't scan OpenWrt format for a single one. 0 findings, and not because the image was clean. The path bug had been hiding a capability gap. Fixing it alone would have produced a scanner that was honestly useless instead of accidentally useless. 2 instructions from me in that stretch, same shape both times. Don't trust it, verify it. The insistence on measuring was the human contribution. That's when it dawned on me, something critical, and honestly why I decided to create this video. Looking at the measurement, I asked the agent one question. Since we're relying on OpenWRT's base here, don't they control the majority of the packages? The agent checked. The manifest is about 200 packages, and every single one is OpenWRT's. My repo contributes configuration, 0 packages. OpenWRT's security team already tracks CVEs across the set. Their fixes ship as point releases, so scanning packages I don't patch with tools that can't read them was the wrong question entirely. The right watch is, am I building on their latest release? The agent retired the scanners and built the replacement inside the hour. Read the pin version, ask the release server for the newest in the series, compare, open an issue on drift, a few lines of shell. I want to be precise about the division of labor because this is the honest part. The agent found the dead scanner, and the agent would have happily shipped a better scanner. Reframing whether scanning was the job at all came from me. Domain judgment picked the destination. The agent made it real and validated it before the day ended. Both the firewall and the OS watches shipped the same way. Detect only, issue on change, human decides. Both had to pass the house rule. No watch is trusted until it catches something real. The firewall currency check caught a point release we were behind on the day it went live. The Node OS watch, built on Buildroot's own CVE tooling, returned 541 findings on its first run. That number is where the second back and forth happened. 456 were kernel version string noise, including a CVE filed in 1999 flagged against a 2026 kernel. My calls, the agent implementation, exclude the kernel. Track kernel currency through the LTS tag instead, gate everything behind a checked-in baseline so the job only speaks on change. Result, 85 real findings, and a flag that pin LTS was 1 point release behind. 2 watches, 2 first runs, 2 real catches. The issues they opened are bench work with my name on it. The watches find the work, they don't do it. And that's the whole method, visible in one problem. Ask about the space with research that attacks its own claims, recon before building, audit what exists, verify what the audit suspects, measure before trusting a fix, bring human judgment to the fork in the road, ship detect only, and make it catch something real before you believe it. The agent did every search, every run, every build in this story. I contributed direction, 1 reframing question, a handful of judgment calls, and every merge. Neither half ships this alone. I wasn't going to read standard error on a green job, and the agent wasn't going to question whether scanning was the point to begin with. One more number, because it's the entire economic argument here. Everything after the research pass happened inside a single day, and the elapsed time is padded by me. I stepped away for lunch in the middle of it. The agent's turnaround on each exchange was minutes. The biggest gap in the timeline is a human eating. For the first time in my career, the schedule bottleneck was me answering questions, not the work getting done. The timestamps are on the public PRs and the runs. You can look in GitHub to check me. Developing with AI gets pictured as autocomplete or as autopilot. This is neither. It's a loop. Ask, verify, measure, reframe, ship, verify again, with a human steering and an agent doing the miles. Every artifact in this story is in public repos, links below, including the workflow that was green for weeks while scanning nothing. Judge the method by its output. As I continue to develop Rasputin using AI and AI agents, look for more videos showing how it's done and how quickly we're moving. The written versions are live at geekdojo.com as well.